Hello, students. Greetings to you all. Hope you are all safe and sound in your respective places. And I'm sure you're all very eagerly waiting for 11th standard result. Let's pray that you all should score well and pass with good marks in your 11th standard. But in the meantime, instead of wasting your time with your mobile games and unnecessary talks and watching TV and movies, it's better to concentrate on your studies a little. So, welcome back to physics class. So far, we have completed chapter 5 and then we started with chapter 1. In chapter 1, we've completed the first half. Now we are giving a small break and moving on to another chapter. Why we are giving a break? Because the first half and the second half will look very similar and it will be pretty confusing. So I want you to take some time and make the first half more, understand it well, and try to learn all the derivations, and then we will move on to the second half of the first chapter. So, which chapter are we going to discuss about now? Which lesson are we going to learn? Unit 10 in your second volume book, the 10th chapter. The name of the chapter is Communication System. So, this is the first session for this particular chapter, Communication System. Okay, so what are we going to learn in this particular session? We will be having an introduction about the chapter, or what exactly does the word mean, and certain basic terms that you need to understand. And then we are going to learn about modulation and its types, and the very interesting topic, elements of electronic communication, and then about bandwidth. So we'll be discussing about all these in this particular video session. Okay. So, what do you mean by communication? If I ask you a question, what is communication? What would you reply? It's nothing but a transfer of information from one person to another person. And this communication can be through words, or it can be through an action, or you can just write and give, or you can even transfer the information through some sounds or expressions. So, in simple words, communication is you're sharing an information or an idea or a content, and this has to be transferred from one person to another person, or one group of people to another group of people. So, communication is nothing but transfer of information or exchange of information, you can say. So, how was this communication in earlier days? How did it all begin? So, before there were any civilization, what was the condition of men? We would call the earliest stage as Stone Age period. And in that period, they didn't have any electronic gadgets or they didn't have any machines. So, how do they communicate? The only way of communicating is through verbal communication. You express your ideas and thoughts through words to another person, or you will also, or you can even write it in a stone or a skin of animal, and you roll it and give it to them. So this is how the exchange of information was happening. And later on, as years goes by, we brought in the idea of communication, and we made it very easy through different mediums. Initially, during the period of kings, they had people who will take the information from one place to another place, and then they used pigeons, and then we had letters, telegrams. So there were methods through which people were communicating. We had telegrams, and then I don't know whether you all know, there was a period when you send a letter to one person, it will go and reach them after weeks, because it has to be taken from one place to another place through ships or through flights, and then it will reach the respective people. And later on, we got this telephone, radio, television, and all. So, when you compare the speed of communication from earlier days to now, what actually has improved is the speed. When you send one information, that information reaches the other person in a moment, within a second nowadays. So these were few of the communication systems used in earlier days. But what is the recent development? The recent development in the communication system is the feather on the crown. We are able to communicate with people even in any corner of the world within seconds, either through a texted message or through a voice message or even through a video chat. How did this all happen? What actually is the reason behind all this communication system, and what actually is making it all very simple and easy? You may think that we communicating with the people on the other side of the globe is the farthest communication distance. For example, maybe somebody is here and that person is communicating somebody in the other corner of the world, and we may think, wow, we are communicating through a very far distance. But you know what? Which is the longest communication that is in trend? People in NASA are communicating with a robo which is found in Mars. If it takes a picture and sends to NASA, the amount of time that it takes is nearly 16 minutes. So imagine you cannot go to Mars in 16 minutes. It takes a very long time, and it also needs a lot of equipment and lot of money has to be spent. But the rover, which is over there in the Mars, is taking pictures and doing some analysis and sending the information to NASA within just 16 minutes. So the recent development in communication is satellite communication. It's the satellites which make it very simple and easy. A long distance transmission in a very short possible time is what we have reached in this recent days. So, for a long distance transition, the low frequency based signal is superimposed onto a high frequency radio signal by a process method called modulation. So our next topic is modulation. Because when I say we are communicating through a very long distance in a very short period of time, how is it possible? I'm standing here and I'm trying to scream, and I'm trying to talk with a person who's right next in the next house. Maybe the distance is like some 3 or 4 meters, but when I try talking from here to there, I have to shout. I have to give so much of energy so that that person can hear. But how does this happen that I am here and I'm able to talk with a person who's on the other side of the globe? That's because we are doing a process to the information. When I say information, it doesn't mean what you are trying to say. It means you are giving out a information. When you speak, you share something, so that signal is what we are going to call it as an information. So something is being done to your information so that it goes and reaches the person who's far away from you. For example, you have a small car. Imagine it is not a remote car and all, it's a very normal car. When you just keep it and give it a small push, it goes only to a small distance. When you give it a when you give a forced push, if you push it with a higher force, you will be able to notice that the car covers the longer distance before. So what are you doing? You are adding some energy so that the car travels from one place to a farther place. So similarly, we are going to do a process, that is, we are going to do a modulation to your information. See, for example, you are going in cycle. So if you are trying to ride a cycle, you cannot go very fast. But if you happen to add a motor to your cycle, what do you think would become to the speed of your cycle? It goes very fast, and you also don't lose any energy. So the exact thing is going to happen here. You are sending information from one place to another place. We are going to add a motor to your information so that it goes and reach to the other place without any loss of information. Whatever you say has to go and reach the other person completely without any loss in the information. So what is this process? What exactly modulation is? Modulation is, you have a original signal. Original signal is nothing but what information you give. So, and you're going to add it to a carrier signal. So you have something, you're going to add it with the carrier signal. So what exactly is this carrier signal? So this is your cycle, and this is the motor that you're going to add with. So what kind of motor is it? What is this carrier signal? It is nothing but a high frequency signal. It's a high frequency sinusoidal wave or a sine wave. We have learnt about sine waves in your second volume in 11th standard book. It's nothing but it goes up and down like this. So that's what sine wave is. And we also learnt about this equation for sine wave, in which you have three important factors. EC is called as amplitude, FC is called as frequency, and this phi is called as phase. Why am I stressing all these? Because we will be learning about it more in this particular session. Amplitude, phase, and frequency. So this particular carrier wave has an amplitude, this carrier wave has a frequency, and this carrier wave has a phase. So this is the character of the carrier wave. So this carrier wave is being added to our original signal, or the information that you are going to send from your place to another person. So you're going to boost your information so that it goes and reaches the destination. Okay. There are different, knowing what modulation is nothing but it is a process in which you are adding your original signal to a carrier signal so that it goes or travels a longer distance. For a longer distance transmission, a low frequency baseband signal, that is your input signal, your own information, is superimposed onto a high frequency radio signal. What is this high frequency signal? That is our carrier signal. So your input signal is added to the carrier signal. Superimposed is nothing but you're simply adding them. So your signal is added to the carrier signal, and it is you in this process, your signal travels a longer distance. Okay, this modulation is of three types: amplitude modulation, frequency modulation, and phase modulation. So these three words is what you saw here in this mathematical expression for a sinusoidal carrier wave. So you have three types of modulation: amplitude modulation, frequency modulation, and phase modulation. We are going to see one after the other now. But before we could go into these modulation, you need to understand the meaning of these four words. First is, what is amplitude? What do you mean by amplitude? Amplitude is the maximum displacement in a wave. What is the maximum displacement in this wave? I would call this as the amplitude. So my amplitude will be here. Why? Because this is the maximum displacement in this wave. Okay, what do you mean by phase? It is defined as the position of a point in a time. See, imagine, let's consider a point here. I'm going to consider this as a point. So here the point, and look at a point here. Are they both in the same place? No. There is a difference in the time. So the small difference in time for a particular point is what we'll call it as phase. So we will be this phase is basically compared for two waves over here in this picture. You have a red wave and a blue wave. The red wave and the blue wave are not in phase, which means the maximum of red wave and the maximum of the blue wave are not in the same position. They are in different points, and the distance between the points is your phase difference. What do you mean by frequency? The number of oscillations in a unit time is what we call it as frequency. I know you're very familiar with amplitude and frequency. Phase is pretty new word, but you will be understanding it very clearly as the lesson goes by. The last one is called as bandwidth. You might have been using this word very often nowadays, because when your internet is slow, what would get displayed on your phone? The bandwidth is low. So here Bandwidth is nothing but a range of frequency. For example, you are having a collection of papers, but your uh, responsible officer or somebody is asking only for papers from number 6 to 24. So that is a range. They are calling from one number to another number. So here, even in bandwidth, you have a range of frequency, maybe like 20 hertz to 200 hertz. So that is the range of frequency, 20 hertz to 2000 hertz, 20,000 hertz to 20,000 hertz. So these are all ranges, or it need not be from 20 hertz. It could even be from 1000 hertz to 10,000 hertz. So these are all range of frequency. Even we have a audible range of frequency, and that you can call it as a bandwidth. The bandwidth which we are audible to. So I'll repeat again, amplitude is nothing but maximum displacement. And phase, I believe you understood that phase is the time difference for a particular point between two different waves. And then frequency is the number of oscillation in a unit time, and bandwidth is nothing but the range of frequency. We'll start with amplitude modulation. What do you mean by amplitude modulation? Modulation. When I say the word modulation, you would have heard you talk, people talk, and even you would have used this word, voice modulation, right? When you change your voice a little, you call it as a voice modulation. So modulation simply means you are bringing a change in the original thing. Your voice could be something different, and you try to talk like somebody else, you would say that you are modulating your voice. So here we are going to modulate the amplitude, which means we are going to change the amplitude. Okay, so see here you have a signal wave. This is your input signal. Okay, so you have a input signal, or you also call it as a baseband signal. Okay, don't forget, you can call it as a baseband signal or a input signal. And then you have a carrier wave. What do you mean by carrier wave? A sinusoidal wave with a high frequency. See its frequency? The frequency is very high for carrier wave. So you have a signal wave and you have a carrier wave. For amplitude modulation, what we would do is we would simply combine. It is nothing but the superimposing or adding both the input wave and the carrier wave. So this input wave and the carrier wave, we are simply going to combine. So when you combine, you will have a resultant wave. This is your amplitude modulated wave. So I think you are able to see the difference in the amplitude modulated wave. Here, the frequency is high. Here, the frequency is low. Also, the amplitude is also different between an input wave and a carrier wave. So, when you add both these, you have a very different form. It's more like mixing two colors. You take white and you take black. When you mix them, you get gray. So, similarly, you have two different waves. You add them both. When you add them both, what happens is you have a new wave. And why do we call it as an amplitude modulated wave? Because you can see the amplitude of the wave has changed. If the amplitude of the carrier wave or the carrier signal is modified in proportion to the instantaneous amplitude of the baseband signal. See here. So this is your signal wave and a carrier wave, one on the other. Okay. You know, this is your signal wave or your baseband signal. And this is your carrier wave, the one with the high frequency. So we are going to add both. What will happen? Here also it is a maximum amplitude. So the maximum amplitude comes exactly the way it was. But here the amplitude is decreasing. So when the amplitude decreases, what happens? Here there's a small change in the amplitude. Plus 5 is equal to 10. But plus 5 minus 5 would become 0, right? So plus 5 minus 2 would become 3. So when you are adding a positive value and a negative value, your actual value decreases. So here you have two different amplitudes, one maximum amplitude and the other minimum amplitude. When they both join, there is a change in amplitude in the resultant wave. So this is your modulated signal. So very simple. What do you mean by amplitude modulation? If you happen to understand amplitude modulation, frequency modulation and phase modulation are exactly the same. So try to understand this amplitude modulation. In short, we will call it as AM. What exactly do we do in amplitude modulation? You have an input signal, and you have a carrier signal. You are going to add both. When you add both, there will be a resultant wave whose amplitude is very much altered because of the combination of these both. But what we have mostly, we have a carrier wave. It resembles, see, the frequency is very similar to that of the carrier wave. So you can also call that when you are adding the input signal to the carrier wave, the amplitude of the carrier wave is altered. So this is what you call it as an amplitude modulation. So what are the advantages and disadvantages? In the case of amplitude modulation, it is easy to send or receive the signal or the information. It's very easy to send or receive, but the bandwidth is very less. If you increase the bandwidth, for example, it could be only between 200 to 8000 hertz. If I happen to go beyond 8000 hertz, this amplitude modulation does not work. And also, it is a very low cost system of sending information. So what are the limitations? Noise level is high. What do you mean by noise level? When you are recording your voice, you would say noise is more. You will have a unpleasant sound behind going along with your voice. You call that as noise. So similarly here you are sending your information from one place to another place, but your information will go along with some jarring sound, noise. So what happens whenever there is noise? Your information is not efficiently sent. Your information cannot be heard properly. So it is very low efficient, and as I told you, the bandwidth is less, so it operates in a low range. Moving on to frequency modulation. In the earlier case, what we saw in amplitude modulation, we had a input signal, we had a carrier wave, and we had a modulated wave. Similarly here, we are going to do the same. But here, what is going to be altered is the frequency. The amplitude and the phase will remain same. In the case of amplitude modulation, it was only the amplitude of the carrier wave that was altered. The frequency of the carrier wave was exactly the same. Here, what is going to be altered is the frequency is going to be altered, but the amplitude is going to be the same. See, this is your baseband signal. This is your carrier signal. This is your modulated FM, frequency modulated signal. But here you can see the amplitude remains the same. What is changing? Only the frequency is changing. When you combine both these signals, when you allow only the frequency to change with respect to the input signal, then you call it as a frequency modulated signal. See, your input signal and the carrier signal, when they combine, you get an output. The output has the amplitude exactly as that of the carrier signal, but only the frequency changes. So what are the advantages? Certain disadvantages which we had in the amplitude modulation are being rectified in the frequency modulation. So we'll see what are the advantages. You have less noise. So when you have less noise, what happens? You have an efficient transmission. Whatever the information you are sending will go and reach well. And the operating range is high. That means you can work on higher bandwidth. But what are the disadvantages? You require much wider channel because the bandwidth is high. You'll have a wider channel, and it's very costly. Earlier case it was very cheap, but now it's costly. So we have certain disadvantages even in the case of frequency modulation. So this is a small combination of frequency modulation and amplitude modulation. See here, in amplitude modulation, The frequency is same, but the amplitude is changing. But in the frequency modulation, the amplitude is same, but the frequency changes. Okay, the last one, the phase modulation. I told you what is a phase. Phase is the positive, the this and this. If when they are in the same point, you will call it as they are in phase. This point, this maximum and this maximum, this they are in the same line, you will say that both these are in phase. See, for example, this maximum and this maximum, they are in the same line. So I would say that this green wave and the blue wave are in phase. But that is not the case here. See, they are not in phase. They are going out of phase. There is a time difference between them. So here, when you are combining your input signal and the carrier signal, what happens is there is a change in the amplitude. So here you had change in magnitude, amplitude, and you had change in frequency, but here you have a change in phase. In the phase, if the phase of the carrier signal is modulated with respect to the input signal, then you results in a phase modulated signal. So here the phase modulated signal, the maximum point of the carrier wave and the maximum point of the modulated wave will not be same. This particular phase modulation has more advantages than disadvantages. The more best advantage out of all is it's a very stable signal. So when you call it as a stable signal, it cannot be disturbed, or it will not be, you won't have any noise, and you can send the information very clearly from one place to another place. So these are the three different modulations. Input signal, here amplitude is modulated, frequency is modulated, here the phase is modulated. Okay, so now moving on to the next important topic, the elements of electronic communication system. So if you have to send your information from one place to another place, it cannot be done very simply like having a face-to-face communication. Your signal has to undergo so many processes before it reaches there. So what exactly are the processes that are happening here? See, for imagine that you're going to gift somebody something. So you buy a gift, you will not just go and give it right away. You'll remove the rate tag from it, and then you will put on some gift wrappers, then you'll put on a bow on it, and then you'll add a sticker, and then you will go and hand over it to that person. So what does that person do? That particular person whom you have gifted will take away that bow, will take away that sticker, and then will have to take away that gift wrapper to get the gift. Should you just imagine that the same thing is going to happen here as you try to send your information from one place to another place. From your point, your information is wrapped beautifully in a gift wrapper and is sent it to the receiver. And what does the receiver do? He removes all the gift wrappers and sees the gift. So you have an information. Your information is passed through the input transducer. What does the input transducer do? The input transducer, an input transducer, it converts your input signal into an equivalent electrical signal. So the work of an input transducer is to convert a signal to an electrical signal. And your signal is then amplified. Amplified is your volume is raised, and then it undergoes a modulation. It could be either AM, FM, or PM. And then this information is taken through the antenna, and then it reaches the receiver through a channel. And what does the receiver do? Here you modulate it, here you demodulate it. How do you modulate your signal? You are adding your original wave plus carrier wave. What do you mean by demodulation? Modulated wave minus carrier wave. You get your demodulator. And then your uh, original signal is being detected, and that original signal is amplified, and then it undergoes the output transducer. What does the transducer do? It converts your signal to an electrical signal. This output transducer will convert your electrical signal to the information that you are sending. Your information could be a voice information or a picture or a movie, or it could be a text. Okay, your text or your picture was initially, this is their picture, it is converted to your electrical signal, and that electrical signal is amplified, then it is modulated. It could be one of the either three modulation, and through the antenna and through the channel, it is sent to the receiver. The receiver gets it and demodulates it means he takes out the carrier wave and takes only the signal, and your signal is amplified because it has traveled a long distance, so it have lost some energy, so it is amplified. So your electrical signal is again converted to the actual information that you sent, and it is given to the person whom you wanted to send. So this is called as the block diagram. So this part, your sending part, is called as the transmission, and the receiving part is called as the reception. So we'll have a quick glance of what everything means. What do you mean by the information source? Information source is the information that you send. As I told you, it could be anything, your text or your audio, video, or any information that you send. You can call it as the original info source or the information. And this go is being transmitted from one place to another place. So what happens in when transmission takes place? Your signal is being amplified and it is being modulated. So here, in order to amplify and to modulate it, we will be using certain electrical circuits. Only through the circuits this transmission takes place. Even modulation is also done by a electrical circuit. And then once your signal is ready, once your gift is all wrapped, it has to taken from your place to that particular person whom you want to give. And that's what you do in the transmission. So how is it being transmitted? It is being transmitted through cables or through antennas. In the case of antennas or cables, and then it could also be happening through the communication channel. What do you mean by communication channel? A communication channel is used to carry the signal from the transmitter to the receiver. So you are sending it out through a antenna, and it is again received through a antenna. You're throwing your ball and the other, you're throwing your ball through one antenna, the transmitter antenna, and it is being caught by the receiver antenna. Mostly in the case of a wireless communication. In the case of wireless, in the case of a wired communication, we will be using cables. So antenna in the case of wireless communication, and cables in the case of wired communication. So who is the receiver? The person who receives your information. So your information is collected through the antenna and it is being demodulated. Demodulated is you are filtering out the carrier signal. If you take out the carrier signal, you will get your actual input signal. See, for example, when you watch TV, the information is being scattered through the satellite to every single place. But you will have to change the channel in the TV so that you will see that particular information. So you have to choose the channel to receive the information. So anything that receives the transmitted information and capable to store them is what you call it as the destination. But here in your destination, you can have any type of information that are scattered in the space. For example, your TV channels. There are so many channels, but you choose the channel and you see what you want. Noise. Like we saw in the case of amplitude modulation, it always accompanies a lot of noise. Noise is the unwanted, you are sending your information in the form of electrical signal. Some unwanted electrical signal will come and combine with your electrical signal. You will have to remove it. So in short, we can say that your information goes through a transmitter. Inside your transmitter, you have this amplifier, modulator, and then through the channel, it goes and reaches the receiver, and it goes to its desired destination. And the other things you need to know is attenuation. What do you mean by attenuation? Attenuation is nothing but loss of strength or energy in your signal. For example, when somebody is shouting from the next house, you will not be hearing the exact volume of that person in your position. The volume is less when you hear. When the person is talking, he simply shouts. But when you hear it, you are not listening to that shouting voice. What you listen is a very feeble sound. So here, what's happening is there is a loss of signal energy when it comes and reaches. So that's what you call it as attenuation. What do you mean by output transducer? A transducer which can convert the electrical signal back to its original form. And the repeaters. Repeaters are used to increase the range or distance through which the signals are sent. So these repeaters are the signals are received, amplified, and retransmitted. It's like you have a when you are going from one place to another place, you take a break and then you travel, take a break and travel. Same thing is being done to the information. You send the information, but it has to go to a very long distance. So it goes to a certain distance, stays there, it gets amplified, and again it goes to another destination place, takes there, gets amplified, and it reaches the destination. That's what you call it as a repeater. And the range, you know what is meant by range? The maximum distance between the source and the destination is what you call it as range. So this range is in distance. If I'm going to call this range in terms of frequency, it is called as a bandwidth. The frequency range over which a baseband signal or an information signal such as a voice, music, picture, or a video is being transmitted is what you call it as a bandwidth. Bandwidth is nothing but a range of frequency. See this formula? BW is equal to F2 minus F1, the upper frequency and the lower frequency. So bandwidth is nothing but a range of frequency. So you have to choose a bandwidth to transmit your information. Bandwidth of transmission system. So when we see the bandwidth of transmission system, each transmission system can have a unique bandwidth. The range of frequency required to transmit the information in a particular channel is called as a bandwidth. So when you may see you have so many channels in your television like Discovery, you like National Geography, Sun TV, Star TV, and so many. Everything has a different bandwidth. Okay, every channel has a different bandwidth, and that's why we are able to get their signals very clearly without any disturbance. If they all have the same bandwidth, what will happen? Every electrical signal will combine and we will only receive noise and not the information. See here, the speech signal has certain frequency range. What we speak has a frequency range. Music has a frequency range. So video signal, TV signal, everything has a frequency range, and this frequency range is what we call it as a bandwidth. So what we have seen so far is we saw what is communication and how communication has developed, and then we learned about modulation, types of modulation, then the components in the electric communication system, and then we saw what is meant by bandwidth. So students, from this class onwards, I want you all to log into Google Classroom. Go to type www.googleclassroom.com. So when you type, make sure that you are already signed in your Gmail ID. From your Gmail ID, go to this Google Classroom, and when you get into the Google Classroom, you have a plus sign in a corner. In your right top, you will have a plus sign. So click on the plus sign. It will ask create class, join class. You have to give join class. So click join class. It will ask for a code, class code. Type this. This is your class code. So log into the Google Classroom. I have posted the study material for chapter 5 and for chapter 1, and I want you to submit your classwork for all the past few video sessions in the Google Classroom. So this is your Google Classroom code. So make sure that you all submit all your assignments, and the submissions will be noted and will be rewarded.